Hello, another good deal from eBay is here on my bench. This is Alesis SR-16 drum machine. Very popular classic unit. The model is from beginning of 90s, I believe, and it was produced for decades and it is still sold all over eBay, very popular. And this particular unit is dated 95 here, and it was described as producing distorted sound. So let's give it a try. Alright, connected. Let's give it a go. Let's switch it into the preset patterns and play the first one. Oh, the volume control is very scratchy. And I think the sound is a little distorted in this mode, but the real problem was described with these. Let's turn the volume up. Yeah, here we are. That is a problem. It was described doing this very distorted sounds here when you compose your own patterns. Yeah, something is clearly wrong with this thing. So let's crack it open and have a look. Alright, I removed a few screws and the knob. So now we should be able to open this up. So let's disconnect the front panel. So here we are. Let's put it aside. So how do we proceed here? Well, usually I start with visual inspection first. To see if there are leaky capacitors or maybe a battery. I don't see anything obvious right now, or just to see if any parts are burnt or anything like that, or damaged in some other way. Nothing obvious so far, so I probably need to remove the board, for which I need to undo these plastic nuts and have a look on the other side, and then start checking the battery and electrolytic capacitors and such. So let's do that. Okay, after removing these plastic nuts, the board is out and it looks just fine on this side. So let's check the battery. Okay, I believe the battery is completely dead. It must be a 3-volt battery to retain the settings and such. And it's completely dead. And there is a possibility it leaked and damaged some components, but I don't see anything obvious right now. Maybe I need to desolder the battery to have a better look. And after that I will start checking electrolytic caps and such, and voltages. Obviously that's a good way to start. Measure voltages on let's say on this which looks to be a op-amp for the output, so maybe measure voltages around this thing or this converter. I believe this is a digital to analog converter from Burr Brown. You see this BB logo. I desoldered the battery and I do see some residue here, but I'm not sure it's from the battery. It might be. However, I do see some residue here and here on the board, so it might be from the battery, might be from the soldering process. Well, let's check other things like voltages and such. Alright, let's check a few things. So this side of the board is clearly the one big ground plane, so I need to find something connected to the ground plane, and I believe this capacitor on this side is connected to the ground plane. So let's assume this is ground and check, let's say, the power on this regulator. So the input is 12.3 and the output is, well, 5 volts exactly. So let's check 5 volts here. Yeah, that's fine, and we see that computer is doing fine. Well, let's check the voltage on this op-amp. Pin 4 and 11 should be the power, because it's TL084. Okay, 10 volts almost exactly. Looks fine on the first glance. I tried a few things here. Well, first I tried to clean the board a little, just to see what kind of residue is this, or was this. I managed to remove it from some places at least. It doesn't seem to be from the leaked battery, and the battery doesn't seem to have leaked. I don't see any residue or corrosion here on the battery at all, but I'm not entirely sure still. And then I tried checking electrolytic caps. They look just fine. And then I started checking data sheets, and even traced some circuitry here and there, mostly around DAC, because there is no schematic or anything, not even a block diagram. So I have some vague idea what's going on in terms of block diagram, but not exactly. And then I noticed something which looks promising in terms of investigation. So here is a page from a data sheet for the DAC, and here is the negative supply, which is minus 5 volts in our case, positive supply, which is plus 5 volts, and here is this from negative supply, this circuit with trim pot to adjust what they call MSB error. This stands for most significant bit error, and it's connected to noise in some way. It's mentioned in the data sheet. So let's check what's happening around this. So let's have a look at this circuit on the board. We are interested in these three resistors and the trim pot. So we should see a resistor from negative supply to trim pot, then from trim pot to pin 1, and then one more between trim pot and pin 27. So let's have a look. Here they are. One is from pin 1. This resistor goes to this pin on the pot. Then from negative supply, which is pin 28, this resistor goes to this side of the pot, and from the wiper on the pot, this resistor goes to pin 27. So let's see, did I turn this on? Yes. Let's check. I will put this to the ground, and let's see. So pin 28 is sitting at minus 5 volts, pin 26 at plus 5 volts, and then pin 27, which is the trim voltage, at minus 2. So here is this resistor from negative supply, goes to trim pot, and on that side we have 3.4, and the same thing here on the pot. And on this side we have pin 1 sitting at 2.5 positive, same thing on this side of the resistor, then 5 volts on this side of the resistor, and same thing here on the pot. And the same thing is slightly higher even. So here we had 4.9 and 5 volts exactly on this wiper contact of the pot. And through this resistor, it's connected to pin 27, and as we've seen, this pin 27 is sitting at minus 2. So here is what we see. This point is sitting at minus 2, this point at minus 5, so this point is sitting at positive 2.5, and then suddenly here we see plus 5 and plus 4.9. So it seems to me that here somewhere there is a short to the positive rail. I removed DAC from the socket and have a look at this. So this wiper is connected to this resistor, and then this side of the resistor is connected to pin 27, and have a look, there's this guard trace all around that connection, and it's connected to the wiper, and guard traces are protecting low current, very sensitive spots from leakage from the adjacent spots on the board through some kind of contaminants on the surface. So that's why there is no solder mask on this guard trace. And you see this this capacitor is clearly the bypass cap on the 5 volt rail connected to pin 26, and the guard trace goes right next to the pin of that capacitor, and well, obviously right next to the pin 26 on the socket. And look on this side, this whole thing is repeated. So there is this wiper contact connected to resistor, resistor connected to pin 27, and another capacitor, this capacitor to the ground from that spot, from pin 27, and again guard trace connected to the wiper, and guard trace goes right next to pin 26, and that pin, that bypass cap, and then it goes away from this area, this 5-volt trace. So I don't see any shorts, neither on this side nor on that side, well, at least without serious magnification. And let's check resistance. So we should check between the guard trace or wiper and 5-volt rail, which is pin 26. Sorry. Here we are. 52 ohms. Not exactly a short, but very close to a short. Certainly something unexpected. I tried using this little tool, scraping between 5 volts and this guard trace like this, and on this side and on this side like this. Here nothing helps so far. I still measure 52 ohms between guard trace and 5 volts. So next thing would be to desolder the capacitor, and if that doesn't help, I would desolder the socket, which is not a huge problem because I have a desoldering station with vacuum. I desoldered the capacitor, which was sitting here. So this is ground and this is 5-volt rail connected to pin 26, and there is that guard trace going right by the pad. And now the resistance between that 5-volt rail and the guard trace increased a little from 52 to 55 ohms. So it's time to desolder the socket. Here we are. This socket is out. So so the resistance increased a lot more to 457 ohms. So I think I see some stuff sitting between, let's say, this pad, which is 5-volt rail, and the guard trace. Some kind of contamination on the board or something, and some stuff here on this side as well. So I need to clean this area with alcohol and measure again. Okay, I did a good cleaning around this area, and look at this now. 240 kilo ohms. That's much better. So let's solder the socket back and give it a try. So I cleaned the socket and soldered it back, and the capacitor as well. And look at this. So this problem with distortion is solved. Now we need to address the Scratchy potentiometer, that volume control thing, and the battery. So for that Scratchy pot I have a couple of things here. One is just pure contact cleaner, another is with lubricant, which is good exactly for this purpose, for potentiometers and such. I need to apply this thing right there, like this, and give it some turning back and forth. And maybe repeat this just in case. Okay, so let's test it. Okay, let's see if it helped. Let's start a pattern and turn this thing. I don't hear any scratching at all, so seems like we are fine. Now let's see what I can do about this battery. I'm sure I can buy a replacement somewhere, but I went through my parts and I found a battery holder like this, which holds a standard 2032 cell, and it happens to match the length between the pins just fine. Well, instead of 3 pins, it's gonna use 2 pins, but it's gonna sit in that spot just fine, no problem at all. Yeah, like this. This should work, no problem. Alright, the battery holder is soldered and the battery is installed. Let's check. So the board is not powered on right now, nothing is connected, and this chip is static memory, which retains the settings and user programmed patterns and such. Let's check. It has 28 pins. Pin 14 is ground and pin 28 is power, and we see 2.9 volts there, no problem at all. I put it back together and it's back in business. Thanks for watching. Bye.